Hello, community. What's going on? My name is Gerardo Lopez. I am CNCF ambassador, and we have another cloud native live. Today, we are diving into a topics that is not just green in Kubernetes, but green for the planet. That's right. We are talking sustainable DevOps, where saving CPU cycles might also save a few trees. And of course, maybe your cloud build. Ever wonder if you idle IAM pods or quietly warning the earth while doing absolutely nothing? Well, Kubegreen is here with the idea to stop the madness. Join us. We explore how the shutdown on youthful or use as resources reduce emissions and look good while doing it. Because who says saving the planet can also be part of your continuous integration and continuous deployment pipeline. Grab your coffee, plant a tree, and go ahead with the topics. Today, we have amazing people, we have amazing guests, and let me introduce Ganesh. Ganesh is our first guest today. Ganesh, welcome to this Cloud Native Live. Remember, people, you can ask all the questions. We respect all the opinions because we are inclusive. So, Ganesh, welcome to this session. I am excited to learn more about the topic that you want to present. Welcome again.
Thanks, Falcon, for having us.
All of you, I don't know if you are you ready? We can start when you want.
Oh yeah, we are ready.
Go ahead and good luck. Enjoy it.
Thank you. So the first question that we usually ask is the hidden environmental impact of the cloud. Why is the environmental impact of the cloud often overlooked? As more companies move to the cloud and adopt DevOps, we have gained speed, automation, and efficiency, but we often overlook the environmental cost of this digital transformation. Data centers, which power the cloud, are massive consumers of electricity. In fact, data centers now account for over 1% of global electricity use, and this figure is expected to double by 2026, which is not that far. It's basically a year from now. And this could potentially reach the equivalent power consumption of a country like Germany, which is amazing. A significant portion of a data center's energy usage is spent on cooling the servers, using advanced air conditioning and increasingly liquid cooling systems to prevent overheating the infra. These cooling systems are essential because servers generate an enormous amount of heat, and without proper cooling, the equipment will fail. One reason we often ignore this impact is that cloud infra feels invincible. Out of sight is basically out of mind. We can spin up servers and clusters with a few clicks without ever seeing the physical machines or energy they consume. This ease of development is great, but creates a disconnect between our digital actions and their real world impact. This comes with an environmental cost. While it's true that environmental impact of cloud computing is generally ignored, because cloud computing is generally more energy efficient than traditional on-prem infra, thanks to economies of scale and resource management, it is not without impact. The redundancies and high availability built into cloud services mean that the total energy consumption, while factoring in usage patterns and efficiency, would actually be closer to traditional setups than we realize. In order to, we can basically say that as you continue to rely on the cloud for our digital needs, it's crucial to recognize and address its environmental footprint. Efforts like adopting more efficient cooling systems, using more renewable energy, and of course, the topic of today's webinar, optimizing resource allocation using tools like Kubegreen, is in the right direction. But the challenge remains, and we need to work together to make this reality. Back to you, Falcon. Falcon, do we have a question there? So the long-term risk of scaling cloud systems without considering the energy sources is profound. Today, most data centers still rely heavily on fossil fuels, primarily because of the explosive demand for computing power driven by artificial intelligence, big data, cryptocurrencies, LLM, that far outpaces the renewable energy that is generated. This reliance is not just a technical issue, it has significant environmental and economic consequences. As cloud adoption accelerates, data centers have become a major energy consumers, accounting for nearly 1% of global energy related greenhouse gas emissions and as much as 2% of global electricity demand. While improving energy efficiency and reducing consumption are valuable, the ultimate goal should be net zero computing. It doesn't matter if you're going down, our goal should be being net zero. Net zero strategies involve not just using less energy, but actively sourcing it from renewables, leveraging innovations in server technology, and optimizing resource usage to minimize waste. This isn't just an environmental issue, it's an economic and social issue. Every time we spin up a new server without asking where the energy comes from, we are locking ourselves into a high emissions future. We are forcing utilities to delay shutting down coal plants. We are driving up electricity costs for families living near data centers. We are using a lot of water to cool these machines in a world where droughts are becoming the norm. The shift won't be easy. It means rethinking how we design software, how we negotiate with cloud providers, and even how we train developers. Our entire way of thinking has to change. In summary, the unchecked growth of cloud infra powered by fossil fuels risk entrenching high emissions and environmental harm. The path forward is clear. Prioritize net zero computing, invest in renewable energy, and deploy digital technologies that optimize and monitor energy usage in each and every data center. And moving on to the third part of my section, what's one thing DevOps teams can do right now to start thinking sustainably? Treating sustainability as a core part of cloud and DevOps planning rather than afterthought is essential to tech industry's environmental impact. As the IT sector grows quickly, its impact on CO2 emissions globally is rivaling almost the aviation industry. 10 years ago, the talk of the town was how much greenhouse gases were emitted by airlines. But now, nobody talks about the greenhouse gases emitted by these huge data centers and the impact it has on neighborhoods around it. As organizations scale their digital operations, the energy consumed by data centers and cloud infra continue to rise massively, making it crucial for us to rethink how we approach DevOps and cloud computing in general. A practical starting point, maybe even a small step, is to audit non-production environments and schedule off-hour scale downs. These actions, while simple, may appear very insignificant, but could end up actually reducing unnecessary energy usage and carbon emissions. For instance, shutting down idle test servers overnight or on weekends, like similar to a government office, not only saves cost, but also directly lowers your company's environmental footprint. Automating this process, like using tools like Terraform or Ansible, ensures that resources are provisioned only when needed and do not have to run all the time. We also need to perform capacity planning and redundancy planning, and we need to make sure that we keep the environmental impact in mind when we design any cloud infra. In summary, the focus of cloud computing and DevOps has been on speed and automation. It's basically how an end user feels like. They get into a car, turn the key, and drive somewhere. They only see what they see in front of them, like how the car rides or whether it provides a comfortable ride. But they don't realize the part or the work that goes behind the scenes. As engineers, our job is to make sure we use sustainability in each and every DevOps project that we do. Now it's time to add environmental impact as a core part of DevOps. Our technology choices affect more than just software performance. They have real world impacts. Thank you. Over to you, Falcon.
Nice. Excellent. Thank you so much, Ganesh. Right now we have a question. The first question is about, are sustainable DevOps practices gaining traction? What do you think about that?
Yes. As we work with a lot of clients, the first question we ask is like, we talk about how efficient a DevOps architecture is, but we are getting more feedback that we need to consider the environmental impact when we design an architecture. And that's something that as we consider very crucial in like minds. Any project that we do, we always make sure that we have speed, automation, and environmental impact in our mind when we design any infra. Thanks.
Thank you so much. So, yeah, continue.
Yeah, over to you, Rutika.
Yeah, okay. Hi, everyone, and thank you, Ganesh, for giving us that excellent brief about the hidden impact of, clouds. So, as Falcon mentioned, we are also here to discuss about how, sustainable DevOps practices can be introduced into an existing IAM environment, right? So, I would first talk about why IAM environments are such a good candidate for, smart optimization. So, to define IAM in very simple terms, it is the first and last mile integration of any user digital interaction. So every login, every session, every tokens that you see are all managed through the identity and access management systems. So this means that it becomes very foundational for any enterprise apps or systems. So what most organizations do is that they end up setting up multiple environments like dev, uat, qa, so on and so forth, that actually mirror the production environments only at scale but not at usability, which means that these non production environments are running constantly throughout the weekends, throughout the off peak business hours, throughout holidays, which means that these systems are consuming a lot of energy, but those resources are being very sparsely used. So, as Ganesh mentioned earlier, the whole crux of sustainable DevOps is not about reducing the availability, but it is about reducing the waste generated. So, keeping that in mind, uh, these non production IAM environments become a very prime candidate for smart optimization. So now that being said, what I'm going to do is show you a very small demo using, how you can use Kubegreen on two different environments. So here for the demo, I'm going to show you two different environments, which is dev and performance testing. And for the sake of the demo, I have utilized one of the IAM products and I've deployed it in a cluster setup, meaning it has one admin node and three engine nodes running. So let me go ahead and share my screen. Please let me know if you guys can see my screen. Is my screen visible? Oh, okay, awesome, great. So what I'm gonna do is before I get into the configuring Cube Green and all that, the first thing that I'm gonna go ahead and do is set up a watch for the dev and the performance testing environment. So what I'm gonna do is set up a watch here. This is how you would set up a watch. So what this command is going to do is it's going to list all the pods that are running in that particular dev environment and it's going to refresh for every 10 seconds. So you see that the admin and the engine nodes are running. Similarly, I'm going to go ahead and set up a watch for the performance testing environment. Okay, okay, so you can see that it's the same setup here. So now I'm going to start off with the dev environment. What we're going to do is I'm going to quickly pull up the um, yeah, I'm just going to quickly pull up the Kubegreen YAML file. Yeah, just give me one second. Yeah, so this is the YAML file that I was talking about. As you can see, it's a very simple YAML file. And the important configuration that one has to focus on is the sleep time, the wake up time, the time zones, and the weekdays. You can see that the weekdays that I've mentioned here is just a star, which means that the sleep time and the wake time will, whatever I mentioned here is applicable for all days of the week. However, Kubegreen also provides a numerical system for you to pick and choose the days of the week for which you would want to apply all the sleep schedules, right? So for the sake of the demo, it's going to be a star for us. And what I'm going to do is going to go and edit the sleep and wake up time. So let's just say I'm going to put it as 17. Um, since the time here is 11, I'm gonna go ahead and put 20. Yeah, that sounds good. So I'm going to go and apply this. How you would apply is kubectl apply -f. Um, Yep. So what this particular Kubegreen YAML file is going to do is that it's going to scale down all the engine nodes in the dev environment. Okay. So while we wait for it to take effect and scale down, I'm just going to go ahead and configure the Kubegreen for the performance testing environment. So this is the YAML file for the performance testing environment. You can see that it's pretty much the same. There is just additional configurations that I've mentioned here. So what this additional configuration is going to do is that it's going to scale down only two of the engine nodes and have at least one engine node up and running. Okay, so in the dev environment, we scale down all the engine nodes. In the performance testing, we are scaling down only two engine nodes. So this is just to show you how flexible Kubegreen as a tool is and how you can use it according to the user's choice. So let me go ahead and edit the time. So we put it as 11, 17, up by 20. Yeah, apply -f. Okay, before we apply, since it's already 17, I'm just gonna go ahead and change it as 19 and this as 23.
In the
-f.
meantime, we have a question from the community. So it is about,
Yeah.
hi, nice to catch. I have wonderful question. I was curious about while using GitOps Argo CD with Kubegreen, is that possible? Because when I'm trying to sleep my pods, again, Argo CD. Okay, it
Oh
seems,
yeah, absolutely. So Kubegreen, can be easily or seamlessly integrated with your current CI/CD pipeline. So, which means that since Kubegreen also follows the same, Kubernetes YAML configurations, it's easy for one to, versionize it and also be able to automate it through the pipeline. And Kubegreen also aligns with the GitOps infrastructure as a code practices, which means that you can streamline the reviews, you can streamline your deployments and the test.
yeah, exactly. This other question that we have, can Kubescreen be integrated into existing CI/CD workflows, or do we need to integrate separately?
Yeah, yes, it can definitely be integrated into your CI/CD workflows, as
Yeah,
I said. Yeah,
thank you.
yes. So now that the dev sleep info has kicked in, you can see that these the engine nodes have scaled down and only the admin node is running. So you guys might have this one doubt as to, like, would it disrupt the current environment? So the sole purpose of Kubegreen is to make sure that it scales down and scales up the pods without causing any disruptions. So which means that for an organization who's about to start their sustainable DevOps journey, they can go ahead and leverage tools like Kubegreen. But in addition to these tools, what one can do is also, set up metric monitoring, also go ahead and deploy a health check scripts or set up alert systems just to, send out notification if something goes wrong. So that being said, I'm also going to show you how you can, monitor your metrics, right? So what I'm going to do is go ahead and bring up the Prometheus dashboard. So Prometheus dashboard. You can use this dashboard to go and measure your metrics. The metrics that I'm going to measure here is the CPU usage. Okay, let me go get the correct environment. So there you go, instead of environment. Or we can also go to the, yeah. Okay, you can see here that the CPU usage for the engine nodes had significantly gone down and has become almost non-existent since the sleep time kicked in, right? And you can see that the CPU usage spike goes up once the pods are up and running. So this is how you would measure your metrics. I can also go ahead and show you how you can use this Prometheus dashboard to have a look at your historical data. So we do have another dev environment where we have used Kubegreen. So beautiful. As you can see here, what we configured for this particular environment is that the pods are going to sleep through Mondays, Tuesdays, and on Wednesday it's going to kick back up at around 10, and it's going to scale down again at 11. So you can see how the pods are being able to scale down and scale up, and how Kubegreen is taking place almost instantaneously, right? So this means that the dev team doesn't really have to do any configuration changes on their end, and the Kubegreen kicks in and you can see the trend. And it also means that the energy that's consumed is less without causing much disruptions, and it's also pretty cost effective for the organizations. So I would also say that I would also love to end my demo by giving you pointers if somebody wants to start how the sustainable DevOps in their organization, how they can go about doing that is by first, auditing your environments and identifying the non-production low risk environment to begin with. And they can go ahead and apply the Kubegreen configuration similarly as to what I showed in the demo. So they can go ahead do that, and they can almost instantaneously see Kubegreen take effect. So this this is a tool that can be used effectively for organizations, and it also means that once the organization is comfortable, setting up their low risk environments with Kubegreens, they can easily work their way up. Yeah. Thank you. Over to you, Falcon.
Nice. The last question that the people have for you is Kubegreen limited to scaling deployments, or can be handled stateful set, cron jobs, or other Kubernetes resources too?
Oh, okay. That's actually a good question. Kubernetes is not just limited to scaling with the deployments. You can also apply it to stateful set and cron jobs. It's just that you need to have the right sleep information configurations. So for Kubegreen, that provides something called scheduled cron sleep variables that you can configure. And for stateful sets, you can use something like patches, just like how I showed in the second use case of the demo, right? So you can use patches to scale down your stateful sets. But we would suggest that you start off with the stateless environments, and when you get comfortable, you can expand to the stateful sets.
Nice. Thank you.
Yeah.
Thank you so much. We're moving to the next one, right? Okay. Welcome to the stage.
Thank you for having us. Okay, so yeah, let me get started. So thanks, Rubika. That was really eye-opening, because it's like one thing to talk about optimization, but actually seeing those pods sleep in action and the real savings they bring, it really makes it feel doable. So to begin with, I mean, we just saw how Kubegreen configures the pods to sleep at those given schedules, and we saw how they behave throughout a period of time, right, via the Prometheus dashboard. But the question arises like, okay, but what does that actually mean for the environment, right? So that's what I'm hoping to answer here. And the thing is, like, at first, it might not seem like a big deal. I mean, like scaling down a few pods overnight, like one could ask how much could that really matter, right? But over time, it actually adds up because every pod that goes to sleep is using a little less energy. And less energy means fewer fossil fuels burned, which directly cuts down on our carbon emissions, right? And as my colleague Ganesh mentioned earlier, a lot of our cloud infrastructure still runs on non-renewables, even today. So reducing usage genuinely helps reduce emissions. Um, the thing is, like, it's easy to dismiss, right? Because it may be just one dev environment here or a performance environment there across one organization. But when this becomes a habit across hundreds of teams, across different companies and regions, that's when it really starts to matter. And all those pod sleeping hours really begin to stack up night after night, week after week. So you're not just saving money on your cloud bill, you're making, your part of the cloud a little bit greener. And as my colleague Rupika just demonstrated, it just takes very minimal engineering effort. Just applying a few Kubernetes YAML manifests will configure these pods to take a break when they're not expected to do anything. And also, like, the next question could be, why, like, once we have applied this, how do we really see the results, right? So how can teams calculate the actual carbon footprint from the Kubernetes usage data? So to answer these questions, I thought I would walk you through a little bit of how we do the calculations, and that'll help you understand it way better. Now let me start sharing my screen. I hope you can see my screen.
Yes, we can see your screen.
Oh, fantastic. Thanks. So extracting from Rupika's YAML config, she basically set the pod schedules across two Kubernetes namespaces in our example. So we have the pod schedule across weekdays and weekends as well, right? So approximately that's around 80 hours of sleep for the pods. And then across the weekends, that's about 96, right? So totally per week, we have the pods sleeping at around 176 hours each, right? Obviously, like, we cannot see the impact of environmental savings right now. So that's when we can use a tool like the Kubegreen CO2 calculator, which allows us to calculate your carbon dioxide equivalent, right? So let's go ahead and take these hours. So that's 167 hours of sleep per week. And in our cluster, we do have like 34 pods running, out of which 6 pods are configured to sleep at the schedule. And as you can see, right, we have significant savings already from this cluster alone, right? That's around 86%. So without Kubegreen per week, we're looking at around 7 kilograms of CO2 emissions a week. And with Kubegreen, that is potentially reduced to just 1, which is basically a savings of 6 kilograms a week. So let's put the total hours of sleep over here just to give you an understanding of how this looks like in the macro. So over a period of a month, we're looking at like 704 hours of sleep, and over a year, you can see how that stacks up, right? That's 8,448 per year. And let's grab the CO2 saved per week, just add that over here. And as you can see, per month, this equates to about 24 kilos, and that equates to around 288 kilograms of CO2 emissions per year in just this non-production environment where we sleep merely 6 pods according to schedule. It's a pretty big impact, right? Still, this is just the kilograms of CO2. So it's really tough to conceptualize what these emissions look like, right? Like we need to be able to have a better way of visualizing what these numbers really mean. And for that purpose, I really like to use this tool that's provided by the United States Environmental Protection Agency, which gives us a greenhouse gas equivalencies calculator. So what I'm going to do is just go ahead, go to our emissions data, and let's just enter the CO2 that we have saved up, right? So we got about 288. Let's add that to carbon dioxide, and that's kilograms. Let's convert that data, and boom, like there we go, right? So by the simple act of sleeping a few pods during the scheduled downtimes, you can get an idea of the potential savings in CO2 emissions, right? So that's like 32 gallons of gasoline consumed, 320 pounds of coal burned in just one environment. So imagine this being scaled across multiple clusters across organizations, and you can really start to see a small change like applying a Kubegreen config, making a really big impact to the environment, which is not something you can just brush off. This is quite significant. And so I think I'll step to the next section. Just give me a second.
In the meantime, we have other question. It is not Kubernetes cluster autoscaler already supposed to save resources? Who is Kubegreen different, and why should we bother using it?
Oh, that's a perfect segue to the next step I was actually going to cover. So the thing is, like cluster autoscaler and Kubegreen, they solve two different problems. So the purpose of cluster autoscaler is that it basically adds or removes cluster nodes depending on the demand, depending on the resource utilization, which basically makes it a reactive solution, right? So it acts based on your given metrics at any given time. Now, the thing is with Kubegreen, it is a solution that puts idle pods at scheduled times during nights or weekends. So it is a proactive solution, right? And this is perfect to use when you have predictable downtime, like after office hours, for example. And the thing is, like, even though you have cluster autoscaler, the idle application pods still waste energy when they aren't busy, right? Because you still have resources that's allocated for them. So there's no guarantee that a cluster autoscaler will actually kick in. Now, with cluster autoscaler and Kubegreen working together, like Kubegreen would basically sleep your pods at any given time, and that would release your CPU and memory. So with that reduction of resource utilization, that's when the cluster autoscaler can actually come in and reduce the size of your nodes as well. So they both work together. And it's not like we can have either or, but we should be having both of them, ideally.
There is other probably similar is unlike autoscaling option like HPA, this solution demands manual calibration. Is there a way that cluster can be observed and based on traffic?
I think, is there a way that a cluster can be observed and based on traffic? So this, I think she is, Anita is referring to how the clusters would react based on a metric, right? So that's the job of a cluster autoscaler. That is the like Kubernetes native solution, which is the perfect use case for the cluster autoscaler.
Nice. Do you need to share the screen to on or?
Yeah. So just gonna. Yeah. So with that walkthrough and with that question, like I would like to thank everyone for joining us. And if you have any more questions, we're happy to take them.
Yes, we have other question. It is. They say, do you follow these practices in like minds? When and how do you deploy it? I think so. Ganesh is. Let me come back to Ganesh on the stage.
Answer that. I would like to answer this question. Like in like minds, we care deeply about the environmental impact of DevOps, and this is something that we always practice when we recommend the architecture or implementation to any client. So the first thing we always do is when we do capacity planning or any sort of initial planning, we always consider like, do we need this many pods or do we need this many clusters? What would be the purpose of each environment? This is something that we start off before we actually do any work. And I think that should be what all companies should be doing to make DevOps sustainable. Thanks.
Thank you so much. Let
Yes.
me see if more
There was a
questions.
question like, what happens if a pod is under high load right before sleep time? Like Kubegreen does not work based on load or user traffic. It's based on a set off and on time. So I think by using the auto scaling with Kubegreen, that's where you can actually account for this part when there's a high load period.
Got it. I don't know if there are more questions from the community. Let me see a little bit. I don't know. In the meantime, Ganesh, do you have any invitation or probably any things that you want to talk to the community, probably prove the tool or how the people can be involved with you and the community in order to continue probably contributing or why not prove or test the tool itself?
Sure. Like basically, as we mentioned, Kubegreen is just a starting point. It's not the end all of all sustainable activities. It's one of the tools that can be used for sustainable DevOps, but there are many other tools like actually reducing the number of data centers and the number of clusters used, like making it net zero strategies. And I'm pretty sure LikeMinds is there to help with all these answers. Tuan, Rupka, please jump in if needed, like if you have any thoughts on the answers.
Yeah, absolutely. We're always. You can just reach out to us through LinkedIn anywhere through our channels, and we're more than happy to help you and like walk you through how you can actually implement this.
Yeah.
Anything else, guys? I think so. No more questions for the community. The topic was so interesting and exciting, but last words or last invitation for the people? I don't know.
Yes. So this is just we are just trying to start a conversation on sustainable DevOps. Like we would love to hear more from other speakers too, more webinars. Sort of like see how we can actually make this stick to everyone. Thanks.
Exactly.
Okay. Thank you so much, all of you guys, for the presentation. Appreciate from the CSCF. Appreciate all the effort that you are doing. This explanation was amazing, and of course, I hope to see you soon in different social medias. And why not test this tool? And the people that are watching, thank you so much again for share this on live session. If you want to share, if you like this, please share. Share to the community, share to your contacts, because this kind of tools don't only save money, can help to continue be our world more healthy, and why not to give our new generation, our sons, your daughters, a better future. So follow the CNCF, subscribe to the Cloud Native Live, and keep learning with us every week. There is always more to explore, from sustainability to security to scaling like a boss. Until the next time, stay curious, stay cloud native, and stay green, of course. See you soon, and bye-bye. Take care, guys. Appreciate it.
Thanks
Thank you,
everyone for
everyone.
attending.
Thank you for
Thank
having
you.
us.
Thank
Thank
you.
you.
Yeah.